Hello and welcome again to FlippedHarber for Algebra 2. In this video we're going to talk about solving radical equations and inequalities. The objectives for this lesson are to learn how to solve radical equations and how to solve radical inequalities. The outline for this video will talk about where radicals fit into the PEMDAS or the SADMEP idea of the order of operations. We'll look at solving equations with one radical. We'll look at solving equations with two radicals. We'll look at an example where it's a fractional power rather than a radical. We'll talk about extraneous solutions and to watch out for them. And then we'll end by solving some radical inequalities. So, the thing to remember is that a radical is a fractional exponent. So when we're talking about the order of operations, or really in this case running the order of operations backwards in order to solve for the variable, you need to wait to do that radical until you get to the E portion of SADMEP, the exponents portion. You want to get rid of anything outside the radical first. And you're going to do that by subtracting or adding, dividing or multiplying before you use an exponent to get rid of the radical. Alright, let's go ahead and take a look at an example here where we have a equation with one radical. In this case, it's a square root on the left side. Now, to get rid of this square root, what I need to do is square both sides of the equation. That gives me x minus 9 on the left, and it gives me 25 on the right. When I add the 9 over, I get x equals 34. Taking a look at this where we have a cubed root, it's the same idea, but instead of using a square, I have to use a cube to get rid of the cubed root. When I do that, the cubed root goes away. I have x minus 2 on the left. I have 8 on the right. I add over the 2, and I have x equals 10. Now let's take a look at an example where we have an equation with two radicals. Now when we talk about solving an equation right now with two radicals, both of these radicals will be the same. They will either both be cubed roots, both be square roots, whatever root, they'll both be the same. And even though we don't see it right now, a very important idea is that we want to get one square root on each side of the equation. To try to square this now to get rid of these square roots would actually not get rid of the square roots. It would move them around. We'd see them disappear in one location and reappear in another location. So it is very, very important that we make sure that we have a square root or a cubed root, whatever root we're doing, on each side of the equation. Now I'll square both sides. This is going to get rid of both of these square roots at the same time. And I get x minus 6 equals 2x minus 4. I start to move things around, maybe subtract the x over, add the 4 over. I get x equals negative 2. Now, I do have a bit of a problem with this answer though. When I try to plug negative 2 into this first square root, negative 2 minus 6 is a negative 8. I can't take the square root of that. Now when this happens, and it's going to happen occasionally, this just basically means that we do not have a solution. You always should be going back and checking these solutions. Alright, let's take a look at an example where we have a fractional power. So a cubed root is the same as a 1/3 power. So the way to get rid of this 1/3 power is to cube to get rid of it. Now I'll cube the other side and I'll get 2x1 equals 8. Subtract the 1 over, 2x equals 7. Divide the 2 over, and I have x equals 7/2. Now, you do have to be careful with extraneous solutions. We're going to take a look at an example now where we have a square root on one side. We have a variable on the other side, but we're going to just deal with this like we have the other ones, where we'll square to get rid of the square root, And I need to remember, I'm squaring that whole right side. I'm squaring a binomial. I don't do that just by squaring the x and squaring the 1. I have to remember to FOIL over there on the right-hand side. So I have negative x minus 1 equals x squared plus 2x plus 1. Now I'm going to solve it like a quadratic. I'm going to get common terms together, all on one side of the equation so that it equals 0. I factor. I have x plus 2 times x plus 1. I set both of those factors equal to 0 and I get x equals negative 2 or x equals negative 1. Now I should really be trying these back in the original equation. When I plug negative 2 into the original equation, a negative x with negative 2 plugged in becomes 2 minus 1. Now that's in the square root. That's not really a problem. The square root of 2 minus 1 is not a problem. But let's look at the other side. We plug in negative 2 over there, and we have the square root of 1 equals negative 1. This does not work, which means that this solution does not work. Let's try my other solution. Plug in negative 1. I'm going to end up taking the square root of 0, which again is okay. Look at the other side, negative 1 plus 1. Well, that's 0, so this one does work. So this solution does work. The other one is extraneous. It's extra. It does not work. Okay, let's talk about solving radical inequalities. We're going to go about this exactly like we go about solving radical equations. In this case, I'm actually going to start by getting rid of that minus 1 that's outside the radical. We are going to have an extra step here because we're trying to take the square root. We'll talk about that when we get to it. So I'm going to go ahead and add the 1 over. So I have the square root of x plus 5 is less than 5. And now to get rid of the square root, I square both sides. And I have x plus 5 is less than or equal to 25. Now you should really be wondering, you should really be asking me right now, do I need to flip the sign? Should you have flipped the sign? Well, remember, we're squaring both sides. We're multiplying each side of the equation by itself. On the left-hand side, I've got a square root. Square roots always spit out a positive number. On the right side, I have a 5. A 5 is positive. So I'm actually multiplying both sides of this equation by a positive number. That does not flip that inequality sign. I'm going to go ahead and finish off solving this, and I get x is less than or equal to 20. Now, that's great, but that's not the whole story. Remember, we're trying to take a square root here, which means that that stuff under the square root needs to be greater than or equal to 0. So when I solve that, I have x is greater than or equal to negative 5. Now I really have to check and see, do these two solutions work together? Are they arguing? Are they getting along? Can I come up with a solution where x is both less than or equal to 20 and it's greater than or equal to negative 5? And it turns out that yes, these get along great. I'm going to write these as one solution though, where negative 5 is less than or equal to x is less than or equal to 20. And that's going to be my solution. Let's take a look at another example. Here I have the square root of 2x minus 4. That minus 4 is outside the square root, so I want to get rid of it first by adding it over. I square both sides. Again, squaring both sides is not going to flip that sign. Divide by the 2 and I have x is greater than or equal to 18. Let's check out what's going on under that square root though. 2x has to be greater than or equal to 0, which means that x has to be greater than or equal to 0. Do these two solutions get along? Is it possible for a number to be greater than or equal to 18 and greater than or equal to 0? Well, it turns out all I need is the x is greater than or equal to 18, and it will by default be greater than or equal to 0. So all I need is this portion for my answer. But don't forget to always take what's under your square root and make sure you create a new inequality where that stuff is greater than or equal to 0. Okay, that's it. We're all set. It's time for you to try some of this stuff on your own. I'll see you in class and I'll see you online.